Good morning, very warm good morning, my dear children. The chapter metals and on non-metals. Now revision class is going on. My dear children, in this chapter, chemical reaction of metals and non-metals, that is very important topic. Physical properties of metal, physical properties of non-metals, difference of metals, difference of non-metals. Students, I think revision on this topic we have completed. So students, which chapter? Revision class is going on, metals and non-metals. Physical properties of metals we have completed, we have discussion completed. Metals are lustrous, metals of high densities. As for example, mercury has high densities, that is 13.6 gram centimeter cube. Sodium and potassium are exceptions. Metals are generally hard. Sodium and potassium are exception which can be cut with a knife. Metals have high melting and boiling point. Tungsten has the highest 3410 degree Celsius. Metals are rigid, metals are sonorous. Why metal articles on rubbing becomes brighter? When a metal has been kept exposed to air for a long time, what do you know? You know, students, its appearance becomes dull due to formation of layer of oxide, hydroxides, carbonates of the metal by slow action of moisture and gases present in the air. This process is termed as corrosion. This is the reason why further reaction between aluminium and air is not possible. This is very interesting things. To what is the question? Why metal article on rubbing becomes brighter? So this is the answer that I told now. Physical properties of non-metals. Opposite of metal. Non-metals are brittle. Non-metals are not ductile. Non-metals are bad conductor of heat and electricity except graphite. Do you know, students, why graphite is the good conductor of electricity? Due to presence of the free electrons. But in diamond, that is, there is no free electrons, so diamond is bad conductor of electricity. Non-metals may be solid, liquid or gas at standard temperature and pressure. Non-metals are generally soft, exception diamond. Non-metals have no low melting and boiling point, exception diamond and graphite. Non-metals have low densities, exception iodine. Now, chemical properties of the metal. Metals atoms have usually 1, 2 or 3 electrons in their outermost shell. These outermost electrons are loosely held by the nuclei. As a consequence, they can easily lose electrons to form positively charged ion. Sodium is metal because sodium loses 1 electron. Magnesium is metal because it loses 2 electrons. Aluminium is metal because it loses 3 electrons. As a result, metals are called electropositive element. What is metal? Metal is the electropositive elements because it loses the electron. So this is the main definition of metal. But if we tell that metal is the substance which is ductile, which has the malleable properties, but this is the physical properties. But actually definition of metal, metal is the substance which has the tendency to lose the electron and from the electropositive ion, from the electropositive ions. Now reaction with oxygen. Metals react with oxygen to form metal oxide, and these oxides are basic in nature. When these oxides are dissolved in water, they give alkaline solution, 4Na plus O2, 2Na2 sodium oxide. When sodium oxide reacts with water, it forms sodium hydroxide, my dear children. Reactivity of metals towards oxygen. All metals do not react with oxygen at equal ease. Reactivity with oxygen depends upon the nature of the metal. Metals like sodium, potassium, calcium react with oxygen even at room temperature to form oxide. Sodium oxide, potassium oxide, calcium oxide. Metals like magnesium do not react with oxygen at room temperature. They burn in air on heating to form corresponding oxides. That is magnesium plus oxygen plus heat magnesium oxide, zinc plus oxygen plus heat zinc oxide. So without heat, the reaction will not complete in case of magnesium and zinc. Metals like iron and copper do not burn in air in strong heating. They react with oxygen only on prolonged heat. That is, heat prolonged means with long duration. If we apply the heat, then copper reacts with oxygen to form copper oxide, iron reacts with oxygen to form iron oxides. Reaction with water. Metal react with water to form metal oxide or metal hydroxide and hydrogen gas. The reactivity of the metal depends upon the nature. Number 1. Sodium and potassium react vigorously with cold water to form respective hydroxide and hydrogen gas. Sodium plus water, sodium hydroxide plus hydrogen gas. Potassium plus water, potassium hydroxide plus hydrogen gas. Calcium reacts with cold water to form calcium hydroxide, but the reaction is less violent. The reaction is less violent. This is the second case of the reactions of metals and water. Magnesium reacts very slowly with cold water, but reacts rapidly with hot boiling water, and magnesium oxide plus hydrogen gas is formed. Zinc and aluminium react with steam to form oxides and hydrogen. Zinc plus aluminium, zinc oxide plus hydrogen gas. Aluminium plus water, aluminium oxide plus hydrogen gas. So most reactive metals react with water at room temperature, but less reactive metal react with the steam or the hot high temperature. Iron reacts with water only when steam is passed. Iron plus water, so iron oxide plus hydrogen gas. Metals like copper, gold and silver do not react with water even under strong condition. Fe3O4. So 3Fe plus 4 is 2 equal to Fe3O4, not Fe2O4. Fe3O4 plus 4 molecules of hydrogen gas. And metals like copper, gold and silver do not react with water even under strong conditions. Reaction with acid. Sodium, magnesium, calcium react violently with hydrochloric acid or dilute sulfuric acid, liberating hydrogen gas. So salt plus hydrogen gas will be formed. Aluminium, zinc react with dilute HCl, dilute sulfuric acid, liberating hydrogen gas and corresponding metallic salt. So this is very, very important reactions of metal with dilute acid. So we have to write sodium with acid, sulfuric acid, hydrochloric acid, aluminium plus hydrochloric acid. Reactions very, very important. Aluminium plus sulfuric acid, zinc plus hydrochloric acid, zinc plus sulfuric acid. Iron reacts with dilute hydrochloric acid, dilute sulfuric acid. So iron plus hydrochloric acid, FeCl2 plus hydrogen gas. Iron plus sulfuric acid, so FeSO4 plus hydrogen gas. Copper does not react with this acid. Iron plus hydrochloric acid, copper plus hydrochloric acid. The reaction, there is no reaction. And iron plus sulfuric acid, so no reaction, students. Dilute nitric acid is an oxidizing agent but does not produce hydrogens with metals. Exception in this case there is different process. So students, iron reacts slowly with dilute hydrochloric acid and dilute sulfuric acid, but copper does not react with these acids. So students, if I write here iron plus HCl, so reactions will be completed, that is FeCl2 and hydrogen gas. But if we write here copper plus HCl, there is no reaction. Copper plus sulfuric acid, there is no reaction. Dilute nitric acid is an oxidizing agent. So students, reactions of acid, reaction of metals with water, reaction of metal with oxygen, reaction of metal with acid. So with metal, the three reactions we have completed with acid, with water and with oxygen.